3.3 Problem Solving in Chemistry. Questions. Why do significant figures apply to calculations? How do I know how many significant figures to round my answer to? Why is an orderly process for problem solving important? How do I know whether my answer is reasonable? Terms. How do I solve problems in chemistry? Most scientists perform mathematical calculations in the normal course of their work. Math is an essential tool of science because creating scientific models often involves mathematical formulas. Those formulas are workable descriptions of natural processes. You will learn later that the order established by the Creator that governs the behavior of matter nearly always involves mathematical relationships. Calculations with measured data. When using a calculator to compute the result of a scientific equation, you must be careful about which numbers you report in your answer. You might be inclined to record all the digits displayed in a calculator's answer. Let's compute the density of a sample of the mineral galena, a lead-bearing ore, to understand why we shouldn't do that. We measure the sample's volume to be 5.8 cubic centimeters and its mass to be 44.03 grams. We then calculate the density by dividing the mass by the volume. The result on a calculator indicates that the density is precise to the 100 millionths, 10 to the power of -8, of a gram per cubic centimeter. But the scientist measured the mass to a 100th, 10 to the -2nd, of a gram, and the volume to a 10th, 10 to the -1st, of a cubic centimeter. Therefore, the density result is about 1,000,000 times more precise than either the measurement of the mass or volume. In scientific calculations, the precision of the computed result should have approximately the same precision as the measured data used to calculate it. As with the original measurements, scientists must avoid adding or losing precision. Below are some rules to follow for making calculations with measured data. The rules provided here are adequate for high school subjects, but they do not always yield answers that would be valid in scientific research. Scientists doing research must determine the precision for each calculation on the basis of approved statistical methods. Those methods take into account the types of calculations and the sources and kinds of measured data. Rules for adding and subtracting. Math. Rule 1. Measured data must be of the same dimension and have the same units before we can add or subtract them. You cannot add apples and oranges or meters and grams. Math Rule 2. The sum or difference of measured data cannot have greater precision than the least precise quantity in the measurements being added or subtracted. When adding or subtracting, you must round the result to the least precise decimal place of the estimated digits in the data. Rules for multiplying and dividing measured data. Math. Rule 3. Measured data can be of any dimension when multiplying or dividing. As a general rule, the units for the same dimension will be the same in multiplication and division problems, but there is no restriction on multiplying or dividing meters and centimeters. When multiplying and dividing, treat units as variables using the dimensional analysis process that was mentioned in section 3.1. Math Rule 4. The product or quotient of measured data cannot have more significant figures than the quantity with the fewest significant figures. Round results as necessary. Think back to the density calculation that we did on page 65. Because the volume had only 2 significant figures, the density we calculated should have been rounded to 7.6 grams per cubic centimeter. Math Rule 5. The product or quotient of a measurement and a counted number, conversion factor, or defined value has the same number of decimal places or same precision as the original measurement. In example 3-7 above, we used the formula for perimeter shown below. P equals L plus W plus W. But many of you probably recognized that the formula could be written more simply as P equals 2L plus 2W. The answer using this formula comes out the same as the formula that we used before. P equals 2 times 11.53 centimeters plus 2 times 5.6 centimeters equals 23.06 centimeters plus 11.2 centimeters. 34.3 centimeters. Multiplication is just repetitive addition. Therefore, multiplying a measurement by a pure number should not contradict Math Rule 5. And since division is the inverse operation of multiplication, the same principle applies. Worldview and problem solving in chemistry. Problem solving skills are necessary for daily living. Buying a car, building a house, balancing a checkbook, and even baking cookies all require problem solving skills. When we use these skills as part of fulfilling the creation mandate of Genesis 1:28, we discover more about the creation around us so that we may glorify God and serve our fellow human beings. Chemistry provides opportunities to gain experience in problem solving. You can think of chemists as trained problem solvers. Chemists may be called on to identify unknown chemicals found in a river, to calculate the ingredients needed to make the most effective drug, or to create a plastic that can withstand extreme temperatures. Problems in chemistry are solved by an orderly, reasoned approach with a correct application of the mathematical rules that you learned in the previous two sections. The following page describes a proven, systematic method for solving the chemistry problems that you will face. Steps in problem solving. There are many different approaches to problem solving. Below is a framework for setting up most problems. Step 1. Write what you know. Read the problem. This is the most important step, but it is too often overlooked. Make a list of variables and their numerical values, including their units. Step 2. Write the formula and solve for the unknown. Once you have identified what you know and what your unknown is, you can determine which formula will help solve for the unknown. Formulas are mathematical models of natural phenomena. They relate quantities, whether variables or constants, in literal equations. Those written so that most or all quantities are represented by letters rather than by numbers. Once you have identified the formula, write it down in its standard form. Use algebraic operations to solve for the unknown. Step 3. Plug in known values and evaluate. Replace all the variables with known quantities that you have measured or been given. Cancel units to check that the result has the same units as the dimension for which you are solving. Dimensional analysis. 4. Estimate and calculate. Estimate your answer by using round numbers and mental calculations. Estimating can help you find calculator errors or mistakes in setting up the problem. Finally, calculate your answer. 5. Check. Students are often so eager to get an answer that they fail to check their work. Go back and reread the problem. Did you answer the question that was asked? Is your answer close to your estimate, within a power of 10? Check that your answer has the appropriate units. 6. Record your answer. Once you are satisfied that the problem was solved correctly, round the answer to the proper number of significant figures. Use scientific notation as needed.